Hello, class. This is Mr. Hart, and in this podcast, I want to go over the second part of the pressure and fluids chapter. And to start off, we're just going to talk about what is pressure. Okay, so when most people think of pressure, they think of being under pressure, or being stressed, or pain, or something like that, right? And again, these are a lot of things associated with pressure. Okay, and there's a good reason for that, and we'll get to that in a second. But we want to talk about the actual physics definition of pressure. Okay, and so if you think about what pressure is, it is the amount of force in a given area. Okay, so pressure equals the force divided by the area. Okay, and if you think about that, it makes sense, right? So if, for example, you take a rubber mallet, for example, and you hit your shoulder with it. Okay, if you hit your shoulder with it, it's gonna hurt a little bit, but not much. Okay, rubber mallet to your shoulder is not gonna hurt that much. But if you take a rubber mallet to your pinky, for example, that's gonna hurt a lot, right? Because the force is the same, right? You're hitting the same with the same amount of force, but the area it's hitting is changing, right? When it hits your shoulder, that's a large area. It's probably not going to hurt that much because the pressure is really small. But if it's hitting your pinky, that's a very small area. So that's going to make the pressure go up. So if the area goes down, pressure goes up. Okay, so when we think of pressure, okay, we got to consider how small of an area you're considering, right? For example, here's another one. If you got hit in the head with a basketball, that's going to hurt, right? But if you got hit in the head with a baseball, that's really, really going to hurt, right? Because the baseball, again, has smaller contact area, and so it's going to have a higher pressure on you, a higher pressure on your head, right? And so it can be the same amount of force, but if the area is changing, you can get more pressure on it, okay? So let's look at the units of pressure. So units of pressure are interesting because it's a force divided by an area. So it's going to be newtons divided by meters squared. Okay, and we actually give this a special name. We call it a Pascal. Okay, Pascal, newtons per meter squared. So units of pressure are going to be Pascal. Okay, so let's try one. Say, okay, so a man punches a wood block. If he punches with a force of 500 newtons and his fist has a surface area of 0.004 meters squared, what is the pressure? Okay, so they give us the force. Okay, it is 500 newtons. Okay, they give us the area, which is kind of small. Okay, it's 0.004 square meters or meters squared. Okay, we want to find the pressure. So we're going to plug it into the pressure equals the force over the area. Okay, and so we already have it figured out for what we need, right? We just plug it in. Okay, so we're trying to find pressure. So 500 newtons over 0.004. Okay, and when you plug that into your calculator, you get 125,000. Okay, and again, it's not going to be newtons because it's a pressure, right? So this is actually going to be pascals. Okay, 125,000 pascals, newtons per meter squared. Okay, so there you go. There's our pressure from that punch. Okay, and if you've ever taken karate, you'll learn that you're supposed to punch with your knuckles because that's to decrease the surface area that you hit with. Okay, and that increases the pressure. So that's why if you take karate, you learn to punch with your knuckles. Okay, it's a physics principle. How about that? Okay, so if you're answering this participation, try this problem. Okay, so a 38 special bullet, okay, has a cross-sectional area of 0.0025 meters squared. In order to puncture skin, the bullet must apply a pressure of 345.5 kilopascals. How much force does this bullet apply on the human body? Okay, so think about, make sure you convert this before you plug it in. Okay, but again, try this if you are doing this for participation. Okay, all right. The next thing we want to talk about is the key idea that pain is directly related to pressure, not force. Okay, kind of already talked about this. Okay, the rubber mallet example, right? Hitting yourself with a rubber mallet on the shoulder hurts a lot, or doesn't hurt as much as hitting your pinky because it's a lot more pressure on your pinky. Okay, so pain is directly related to pressure. Another example is if you bump into a door with your shoulder, it doesn't hurt that much, but if you bump into a door with your pinky toe and stub your toe, it hurts a lot, right? And so, again, that's a pressure idea. Okay, so pain is related to pressure. Okay, here's another idea that we want to think about. It's called Pascal's principle. It's the idea that fluid exerts pressure in all directions, right? And this makes sense. Okay, these forces act perpendicular to the surface. So if you put something in water, you're going to feel the pressure of that water in all directions. Okay, so if I put something in water, that water presses down from all directions, not just from one side. Okay, so you can expect compression from all sides. Okay, that's why balloons are round. They feel that force, that pressure from the air, right? But that pressure comes from all directions. Okay, so that's Pascal's principle. All right. So the next thing, we had homework 9. Okay, so make sure you print that off if you didn't do that. Okay. Again, fluids count air and water, so you want to make sure you understand that this is for all fluids. Okay. Last thing we want to talk about is atmospheric pressure, okay, or air pressure. And so air pressure, again, is all around us. Okay, it always pushes from high to low pressures. Okay, so I write it like this: a high pressure will always push to a low pressure. Okay, a high pressure will always push towards a low pressure. Okay, and so air pressure pushes all around us. Okay, and it is very strong. And next time we'll go over some of the effects of atmospheric pressure, what it can do. Okay, and we'll look a little bit more into how we can describe it. Okay, but this is the key idea: is high pressure always flows to low pressure. Okay. But there you go. That's all we're going to cover for pressure right now. Hopefully that makes sense. Let me know if you have any questions, and thank you for watching.